Pavement smoothness, or roughness, is a dominant factor impacting motorists' overall satisfaction with comfort and safety. State agencies such as the Louisiana DOTD regularly measure and report on pavement roughness to evaluate pavement maintenance options and meet federal reporting mandates. Roughness measurements are reported using the International Roughness Index, or IRI.
Measurement methods on pavement smoothness have evolved from manual tools to high-speed inertial profilers, which use laser sensors for accuracy. But these high-speed profilers struggle at low speed because speed change causes measurement errors, especially on ramps, acceleration lamps, and deceleration lamps. As a result, DOTD excludes these sections from performance index calculations, which limit effective pavement evaluation. These limitations created an opportunity to research solutions to overcome these low-speed profiling errors, including circular filtering and improved profilers with additional sensors. Several vendors now offer stop-and-go inertial profilers designed for accurate data connections under varying speeds. This LTRC study evaluated stop-and-go profilers for Louisiana roads, aiming to improve IRI and PI accuracy on ramps and low-speed segments, which will support better maintenance and asset management.
In this study, LTRC researchers used a SAG inertial profiler at different periods in 2022 and 2024 to evaluate and initially compare against conventional high-speed profilers. They tested the profiler under various conditions at 2 DOTD certification sites to assess repeatability and accuracy. After demonstrating reliable performance, LTRC collected IRI profiler data on the DOTD analysis lanes and on adjacent ramps. The study analyzed differences in IRI and PI values and provided insights on their characterization and maintenance strategies. Researchers found that the SAG inertial profiler can produce IRI values comparable to those measured by conventional high-speed inertial profilers at constant high operational speeds. Vehicle speed had no significant impact on the average IRI results obtained from the SAG inertial profiler. The profiler demonstrated accurate and consistent profile measurements under normal constant high-speed operational conditions and under special conditions including acceleration, deceleration, low speed, and stop-and-go scenarios at the LA 414 DOTD certification site. These results suggest that the profiler is suitable for obtaining reliable IRI measurements on ramps, deceleration lanes, and acceleration lanes throughout Louisiana. Researchers noted that pavement sections with extensive distresses, such as cracking and rutting, are not suitable for use as certification sites for inertial profilers.
The research findings lead us to recommend the stop-and-go inertial profilers to obtain accurate IRI measurements for ramps, deceleration lamps, and acceleration lamps. We can reliably calculate the performance index from valid IRI readings obtained from the stop-and-go inertial profilers on special highway sections, including ramps, deceleration lamps, and acceleration lamps. DOTD should consider adopting stop-and-go inertial profilers for network-level pavement smoothness evaluations to improve the accuracy of condition assessments, particularly for special highway sections such as ramps, deceleration lamps, and acceleration lamps. These assessments will help DOTD determine actual treatment costs and the maintenance needs for travel lamps and adjacent ramps.